There is a moon in our solar system with geysers erupting right now, shooting material 8 kilometers into the sky. Its surface is less than 100 million years old, on a moon that's been around for 4 billion years. That means something is constantly erasing it, repainting it with fresh material, and we have no idea what. And here's the part that keeps planetary scientists up at night. The only spacecraft that ever visited this moon spent 6 hours there in 1989. Everything we know about it fits inside 6 hours of data from a probe launched before the internet existed. Its name is Triton. NASA has called it the highest priority candidate ocean world in the solar system. They tried to send a mission and got turned down. In this video, you're going to find out what we actually know, what the models predict, and why the fact that we haven't gone back might be the biggest mistake in the history of planetary science. Quick one before we dive in. Drop a comment right now. Do you think there's life somewhere in our solar system? Yes or no? I'll read through them at the end. Now, here's what most people don't know about Triton. One single fact that changes everything else. Because without it, nothing that follows makes any sense. Here is the rule that every large moon in our solar system follows. They orbit in the same direction as their planet rotates, every single one. It's not a coincidence, it's physics. Moons form from the same spinning disk of material that creates the planet. They inherit its rotation. Triton orbits backwards. That one fact tells scientists that Triton didn't form around Neptune, it came from somewhere else. The leading hypothesis, supported by its size, density, and composition, is that Triton was originally a dwarf planet from the Kuiper Belt, the frozen ring of objects beyond Neptune, where Pluto lives. At some point, billions of years ago, Neptune's gravity caught it, and that capture event was violent. When Triton was first pulled into orbit, it would have been on a highly eccentric path, swinging close to Neptune, then far away, over and over. Those swings created enormous tidal forces, gravitational friction, heat. Models suggest that process was intense enough to have melted Triton's interior multiple times over. Then, slowly, the orbit circularized, the tidal heating faded, and Triton settled into the perfectly round, retrograde orbit it has today. But here's the question that drives the entire scientific case for going back. Did that heat ever fully leave? In 2012, a team of researchers published a study in the journal Icarus. Gaiman, Majumdar, and Roberts modeling what happens to Triton's interior if you account for 2 heat sources: the decay of radioactive elements in its rocky core and the residual tidal energy from billions of years ago. Their conclusion: under certain conditions, a subsurface ocean of liquid water, likely mixed with ammonia as an antifreeze, could still exist today. Beneath an ice shell estimated at roughly 150 kilometers thick. Saswata Majumdar, one of the co-authors, said it directly. I think it is extremely likely that a subsurface ammonia-rich ocean exists in Triton. That's not a fringe opinion. NASA's own Ocean Worlds Roadmap, the official scientific framework guiding where NASA looks for life, classifies Triton as the highest priority candidate ocean world in the solar system. The confirmed ones are Europa, Enceladus, and Titan. Triton is next on the list, and then there's the surface. Voyager 2 images show almost no impact craters on Triton. That's extraordinary. Craters accumulate over time. Their absence means the surface is being constantly replaced. Studies by Schenk and Zahnle, published in 2007, put Triton's surface age at less than 100 million years, possibly as young as a few million. Something is still active inside this moon right now. The question is, what exactly is powering it? Because in 2024, a paper published in the Planetary Science Journal proposed an answer that nobody expected, and it has implications that go beyond Triton. Quick question before we get there. Of all the potential ocean worlds in our solar system, which one do you think is most likely to actually have life? Drop it in the comments. I'm going to read through them. Now, here is where the science gets genuinely strange. Because the new model doesn't just explain why Triton has an ocean, it explains why Triton's surface looks the way it does. And it points to a mechanism that was still active far more recently than anyone thought. In September 2024, N.P. Hammond and G.C. Collins published a paper in the Planetary Science Journal titled Triton's Captured Youth. Open access. You can read it yourself. Their model shows that Triton's high orbital inclination, it orbits at 157 degrees relative to Neptune's equator, creates something called obliquity tides. Even though Triton's orbit is now nearly circular, meaning classic tidal heating is minimal, the tilt of that orbit causes Neptune's gravity to flex Triton's interior in a way that generates heat. Their calculation: this obliquity tidal heating produces roughly 0.3 terawatts of energy inside Triton's subsurface ocean. That is enough, according to the model, to drive active convection, movement inside the ocean, and enough to cause the ice shell above it to fracture and resurface repeatedly. That's not ancient history. That's an ongoing process. This matters because of what Voyager 2 saw in 1989. The geysers on Triton, at least 4 documented eruptions shooting material 8 kilometers high, were puzzling. The leading explanation at the time was solar heating. Sunlight penetrating the transparent nitrogen ice and vaporizing material below like a greenhouse effect in reverse. But solar heating alone has a problem. Triton gets 900 times less sunlight than Earth. It's one of the coldest surfaces in the solar system, at around minus 235 degrees Celsius. The obliquity tide model offers an alternative energy source, one that comes from inside, not above. It doesn't prove the geysers are subsurface driven, but it gives them a plausible internal mechanism that the solar heating model struggles to fully account for. Here's the part of this story that the papers are careful about, but that you can read between the lines. Triton has a young surface. It has active geysers. It has a high probability subsurface ocean according to multiple independent models. It has an ongoing internal heat source that can drive convection. It sits in the same category as Enceladus, a moon where we have already confirmed organic molecules in the plumes. Everything that made Enceladus a serious target for astrobiology applies to Triton, except we've never been back. And here's what makes that uncomfortable. The window to reach Triton with a conventional trajectory using Jupiter's gravity as a slingshot opens around 2030. If we miss it, the next one doesn't come for another decade. In 2021, NASA had a decision to make: 4 missions were competing for funding under the Discovery program. One of them was Trident, a Triton flyby that would have launched in 2026 and arrived in 2038. It would have confirmed or ruled out the ocean, mapped the surface, analyzed the plumes. NASA picked 2 missions to Venus instead, Da Vinci and Veritas. The planetary science community was split. Triton's advocates argued the trajectory window was closing, that you can't just schedule a Triton mission for whenever you feel like it. The orbital geometry has to cooperate. That 2026 was the slot. The 2022 Planetary Science Decadal Survey, the document that sets NASA's priorities for an entire decade, acknowledged this. It recommended that if a third New Frontiers mission call happens in the next decade, a Triton flyby should be one of the candidate themes. That's not a commitment, it's a contingency. Voyager 2 gave us 6 hours at Triton in 1989. 6 hours. And from those 6 hours we learned it has geysers, an almost crater-free surface, and the profile of a world that could harbor an ocean. 35 years later, that's still all we have. If the models are right, if there is an ocean beneath that ice, if those geysers have an internal source, if Triton is what the science suggests it might be, then those 6 hours from 1989 will have been the most consequential 6 hours in the history of space exploration. And we almost didn't notice. If you want to follow what happens with the Triton mission window, subscribe. That decision is coming, and I'll cover it the moment there's news. And if this video made you want to understand what a confirmed ocean world looks like, the next one you should watch is Enceladus. Because Enceladus already has a confirmed ocean, it's already shooting organic molecules into space, and what Cassini found inside those plumes in its final passes is the reason NASA considers it the single most important target in the solar system for finding life. That video is already up.